Hi. Hope you all had a good lunch. This is session 220, Adopting Advanced Features of the New UI in macOS 10 Yosemite. I'm Chris Dreesen, and let me start by showing off some of those new UI features in Yosemite. So to begin with, here's a simple Finder window, and the big changes here, you'll notice the dock is kind of just grabbing the color from the desktop picture. Likewise, the Finder sidebar is infused with the bright pinks and oranges of the desktop picture, and it's really complementing the user's content on screen. Likewise, we have a picture of Safari here, and the content in the Safari window is very different than the Finder window, but the toolbar is just grabbing that color from the web page and making the UI really complement the web content here. And finally, we have Notification Center, which has been around a little while now. But in Yosemite, you can see it's using one of our new appearances, and it's pulling up the really bright reds and oranges and yellows from the desktop picture. And it's not just the background. Also, the text is pulling it up, and the buttons are pulling it up. And we're going to show you how to build UIs that also grab color from the environment like this. So to start with, I'm going to mention a few changes in existing AppKit APIs, especially NSColor and NSImage. Then I'm going to spend a while talking about title bars and toolbars in a section I like to call Title Bars and Toolbars. And after that, I'll invite Corbin on stage to talk about some important new classes that allow you to use these visual effects, particularly a visual effect we like to refer to as vibrancy. And finally, we'll top that off with a discussion of performance regarding these new effects. So to begin reviewing our oldie but goodie APIs, this is NS segment control in Yosemite. You'll notice we have Finder in the background in this picture, Safari in the foreground, and these are the back-forward controls, and these are separate elements now. But they're not actually separate NS controls. This is the same NS segment control as always. We just configured its segment style property with a new value. The NS segment style enumeration has been augmented with NS segment style separated, and this gives you the disjoint appearance between the back and forward buttons. So when you replicate that appearance, don't throw two NS buttons at it. Just use an NS segmented control and this NS segment style. So I'd like to talk about NSImage now. Especially if you've been using UI image, you'll be familiar with some of the things I'm talking about. But let's just start with this little sample image here. This is kind of a button or a bevel or background of some sort. And if you've tried to stretch it using the NSImage API right now, you put in an NSImage view or you draw it yourself, you're going to notice the image is stretched uniformly. So the corners here distort as the image is resized. And that's kind of neat, but if we're going for a button or a window background, it's not really the effect we want. And UI image has had this for quite a few releases, but NSImage now joins it in introducing the cap insets property. And this takes an NS edge inset struct. Thank you. This takes an NS edge inset struct, which lets you specify the distance to the edges to make these caps. And those cap insets are in the image coordinate system. So to review, the NSImage coordinate system begins at 0, 0 in the lower left, the image size and height in the right. Anyway, if you set the cap insets on an image and draw it like you used to resize, you'll note we're now holding the edges and corners constant while resizing the interior of the image. So this lets you get those stretchable buttons, those stretchable backgrounds quite easily. There's one other thing I want to mention about this. So again, if you're familiar with UI image, you know the UI image resizing mode. We now have NSImage resizing mode, which offers stretch and tile options. Stretch is the default. It matches the behavior we've used on macOS 10 pretty much forever now. Tile is a new option. And these are exposed on the surprisingly named resizing mode property on NSImage. Thank you again. So as an example here, this is setting the resizing mode to tile. And Keynote doesn't quite do it justice. There's a crossfade here. But you can see how the image is actually being tiled into these larger sizes. So if you have interesting detail you don't want stretched, you want replicated instead, this is how you would pull it off. And you can use that with any NS button or any NSImage view. So to set up the slicing, I've taught you how to do it programmatically now, but you can also do this with Xcode. And to do that, you just open your image in your asset catalog, and you get a nice preview of it here. Here's my 9-slice checkerboard image. And you can set this up using the IB inspector in this area here. We've got the slicing mode. You have horizontal and vertical here for a 9-slice image. You can also do 3-slice, just horizontal, just vertical. And if you want to change the tiling mode, we have the stretches option here. So you can do that graphically without ever having to change your code. That covered NS image. I'd like to mention a few things about NS appearance in Yosemite. So NS appearance is an API we've had. We're interested in Mavericks. We offered 2 appearances in Mavericks, which you could get at using the appearance named class method on the NS appearance class. And the default is NS appearance name aqua, which is what we've used forever. We continue to use this as the default appearance. And we had this other appearance called NS appearance name light content, which was used by popovers. And in Yosemite, we are saying goodbye to light content. Don't use it anymore. Instead, popovers use one of our new appearance names, which is vibrant light and vibrant dark. And Corbin's going to talk a lot about these in his section, but let me just give you a preview of what these look like. We have vibrant light on the left and vibrant dark on the right. And you can see how the background and the elements are likewise pulling up that color from beneath the window in this case, and how the house image is much more, or offers much more contrast against that background than it might have before. So I mentioned color here, so it probably won't surprise anyone to know that NS color has some notable mentions here. The big one is that system colors are appearance sensitive. So if you use vibrant light or vibrant dark, the system colors are going to return different effective values. So system colors are things like control background color, control text color. There's dozens more. They're in the NS color header and the documentation. We also have 2 new system colors, and that's label color and secondary label color. And Corbin will also talk about these in depth. All right, this is my favorite section here. Title bars and toolbars. We're all familiar with title bars and toolbars, but in Yosemite, they have a new default appearance. And one of the key elements of that new default appearance is that they blur document content. So here's a slightly awkward video of me scrolling a picture in preview. And you can see that as I scroll, the title bar and toolbar are actually absorbing and blurring that content in real time. And preview didn't have to do anything to gain this. They got that feature for free. Let me explain how that works. So if you have a scroll view and it's adjacent to your title bar or toolbar, we're going to automatically draw that previously obscured content, and we'll blur it for you. If your scroll view isn't adjacent to the title bar, we're going to ignore it. So you can see on the left, I've kind of made a mock-up showing the title bar blurring that orange document content, and on the right, it's not adjacent to the title bar, so we're not blurring it or absorbing it at all. And that works really well for almost all content out there, but there's a few cases I want to call out where our magic there can use a little bit of help. So one of those is movie views. This is a big area where we can't just automatically replicate the content for you. Likewise, OpenGL views are in a similar place. You may notice kind of a hardware-accelerated theme going on using the GPU, and that's a good observation. Some types of layers also need a little bit of help in these areas. Movie layers and OpenGL layers kind of get grandfathered in with the views, but other things like layers with 3D transforms and layers with core image filters also require a little bit of help to show up in a title bar and toolbar. Let me show you how you can do that. We have to place them there explicitly, and we can do this using this new Windows style mask called NS Full-Size Content View Window Mask. This is a simple demo app I threw together. This is using a style mask that does not include the full-size content view flag. And you can see our content view is vertically beneath the title bar and toolbar, and this content view just has a slightly odd red box and black box. If we add the full-size content view window mask, all of a sudden the content view size hasn't changed, but the title bar and toolbar are overlaid on top of that content. You can see it blurring the red and the black in the title bar there. So if you look at this mockup and you use the full-size content view window mask, a problem you'll notice is that those controls you used to have at the top of your window are still at the top of your window, but the title bar overlays them. And unless you're trying to play a very intricate mind game with your user, and if you are, your job is done, congratulations, you're going to want to figure out a way to get your controls to be anchored at the bottom of the title bar again. And probably the easiest way to do this is by using auto layout. So NS Window offers a new property called Content Layout Guide, and this returns an object that you can use in a layout constraint, just like you would use in NS View. The example here, I'm creating a constraint which binds the top of my view to the top of the Windows content layout guide, and that means that the top coordinate of both our views is going to be at the same place in the window when auto layout lays them out. If you're not using auto layout, we have a new API in Yosemite on layout constraints called the active property, and you can now install a constraint just by setting it to be active. You don't need to find a common ancestor to add the constraint view, constraint to. In this case, the content layout guide doesn't necessarily have a common ancestor, and this API takes care of it for you. If you're not using auto layout, we have another property for you called content layout rect, and that's just an NSRect that represents the unobscured area of the window. It's key value observing compliant, which means if you register as a key value observer for it, you're going to get called back when it changes. And that's important because it can change. The title bar can change height. The toolbar can have items added or removed, or labels added and removed. You can go from small icon to large icon mode. So it's important to be aware of it. Anyway, assuming we used one of those methods, we can now lay out our buttons beneath the title bar the way we want. They're accessible to the user again. But the scroll view presents kind of a challenge for us. We want it to start off unobscured by the title bar, and we don't want the scroller to be obscured by the title bar either. However, if we just leave the scroll view positioned to take up the entire height of the content view, it will be. So we need a way to fix that. And we have a way to fix that. We have a new API on NS scroll view called content insets. And this just adds margins around the scroll view where it will inset the content view. So in this example, I'm using the content layout rect property of the window and the window's frame to infer the offset between the top of the window and the top of the content area. And I've just gone ahead and set a content insets where its top property is equal to that offset. There's an easier way of doing this. If you do this, you're going to need to key value observe the content layout rect property. Notice when it changes. And a scroll view also offers a Boolean called automatically adjust content insets. And if you set this to yes, it will automatically move or adjust your content so the scroller isn't obscured by the title bar, and the content itself will start unobscured by the title bar. So if we hit back our little simplified example here, this is how the window will look like when it's opened by the user. When they begin scrolling, the scroll view content can still slide under the title bar just the way we want, and we can get this appearance of blurring the document content or the title bar without AppKit replicating it for you. So I'd like to show you another screenshot here. This is a picture of Safari. And something you're going to notice about it is that the title of the window isn't there. Instead, the window widgets and the toolbar share the same row. Likewise, here's a picture of Maps. It's doing a similar thing. Notice the title bar is grabbing that content from the window again, but it's also leaving out the title of the window. So if you want to do this in your apps, it's not difficult. We have a new enumeration called NS Window Title Visibility. It has 3 states: visible, hidden, and hidden when active. Hidden when active adds a little bit of context, so when a window goes to the background, the title comes back. That can distinguish it from otherwise similar windows. These are settable through the NS Window Title Visibility property. So just a quick example, here's that Finder window again. This is title visible, and you can see it has a separate row for the widgets and the title, followed by the toolbar. Whereas NS Window Title Hidden, it's gone. The title bar, or the title's gone, the window widgets and the toolbar share the same row. Here's another picture. This is an app called Reminders. If you didn't know this was Reminders, there's a hint at the top. But you can see the window is divided into 2 sections. They have a sidebar that runs all the way from the bottom of the window to the top of the window, but you'll note the sidebar is not being blurred by the title bar. Likewise, here's a picture of notes, and they're doing a similar thing. The note on the right actually has this nice paper texture to it, and that paper texture goes all the way to the top of the window again. And this is also easy to accomplish. NS Window has a new property called Title Bar Appears Transparent. So if we go back to my silly little red box, black box example, this is it when title bar appears transparent equals no, and that's the default. So you can see the title bar is blurring our content. If we set it to yes, the red box and the black box are unobscured. So you can do tricks like put views that go all the way from the bottom of the window to the top, or otherwise augment the title bar. So I'd like to invite Corbin on stage. He's going to talk about some new APIs that let you take advantage of our visual effects, especially one called Vibrancy. Welcome, Corbin.
Thanks, Chris. So my name's Corbin Dunn, and I'm an AppKit software engineer. So what am I going to talk about today? I'm going to talk about a new class in AppKit to do these blurring and visual effects called Innis Visual Effect View. I'm going to talk about Innis appearance and some materials and how to get that custom colors and whatnot that we have. Then I'm going to talk about vibrancy and how to get that vibrancy and how to do it in your controls and standard controls in AppKit. And then finally, I'm going to discuss briefly some of the standard controls in AppKit that adopt these features and how we do it and how it affects you. So first of all, let's jump right in and go to a demo. This demo is called Visual Effect Playground, and it's not an actual playground app like you might think. But what it has here is it shows a lot of the features that I'm going to discuss today. There are a lot of buttons in this app, and they show each thing that I talk about. Search on the developer site for Yosemite for Visual Effect Playground, and you can find this, take it apart, and play around with it, and figure out how to create apps like this. So some things that it does, if I click one of these images here, it shows how to create basically your own type of sidebar, how to do some vibrancy. There's a couple examples of how to do some type of blurring with a maps type of application, how to get to blur here, and it also will blur under the tile bar too. Another one's showing off our dark look too and how to do something similar to what FaceTime does. So these new visual effects, I'm going to talk about a new class called Innis Visual Effect View. And here's a screenshot of it. And we see that it's blending with stuff behind the window. Here's another screenshot of that demo application, and it's blending with stuff inside the window. And now this is an important difference to note because we have two concepts here. We have behind window blending, where whatever's behind the view and behind the window is blended with what you see. And we have in-window blending. So there are two different modes for this. And so that's reflected in the API for Innis Visual Effect View. There's an enum, Innis Visual Effect Blending Mode, and it has two options, blending mode behind window and a blending mode within window, and then a property to set it. So you can just set it in code, or you can open up your application inside of Interface Builder, and you can go ahead and set the blending mode directly here. It's really easy to do to get that behind window or in window blending. So how does this work? How does the behind window blending actually behave, and what does it do? Well, our implementation is in core graphics in the window server. This means that as your window is moving around, none of the content in your window is actually redrawn. It's managed for you automatically by our window server. What Innis Visual Effect View does is it kind of defines regions with the window server to tell it, hey, this is the area that I want to be vibrant or to be blurred, and do it automatically. The Visual Effect View also implements vibrancy, and I'm going to discuss about that in detail in a little bit. So one thing to note about this and the Visual Effect View with behind window blending, whatever is behind your view inside your application is going to be poked out or knocked out. So if I have this view inside my window and it's on top of an image view, a picture of this elephant, it's going to poke out whatever's behind it. And so it kind of just knocks it out. So it's something to be aware of in your application. So how does within window blending work? Within window blending utilizes core animation to achieve this effect. Innis Visual Effect View uses special layers and special filters to do this work behind the scenes. Core animation is also used to implement the vibrancy, which I'll talk about more in a little bit. Now, if it's using core animation and you set the property to be within window, it requires layer backing. And so this is a screenshot of what happens in Interface Builder if you don't have it layer backed. It'll show it as red to indicate, hey, you're doing something wrong, and you should probably make it layer backed. But you probably don't want to make just your visual effect view the thing that's layer backed. You want to make the thing that contains it be layer backed. So in this case, the content view of your window would be the thing that you'd make layer backed, because it needs to blend those things together, and they both need core animation layers in order to achieve that. So how can you set it? Well, you can also set this easily inside of Xcode if you don't do it in code for the wants layer. And you can just check that box if you're not familiar with it. It's been around for a while. Core animation layer. Now let me talk about some state. The visual effect view has an active state, which we see here, blending with the window. And it also has a non-key or inactive state. So it automatically removes the blurring and just goes to being a solid color fill. This is also represented in API. So the visual effect view has a property called state, and it's an enum value in its visual effect state. And it has, in its visual effect state, follows window active state, which is probably what you want to do. And what this means is when your window is key and your window is active, that visual effect view will be key and active. But you may want to control it more explicitly, so you can explicitly set the active state or explicitly set the inactive state and actually have full power and full control over this. Now, the things about that, as I said before, you want to probably always use the follows window active state value, because if your window becomes key and non-key, it'll automatically do the work for you and you don't have to do anything. You want to use the active state explicitly very sparingly. It can affect performance and battery life, because if you have a lot of the visual effect views around, they're always active. But you probably want to use it in places where you know that view is always going to be active, and maybe it's a panel that can't become key for whatever reason. Internally, we use it in things like popovers and sheets, which always want to have that particular look. So that was discussing some of the basic properties of visual effect view. Now let me discuss how to set the material and how it works with Innis appearance and visual effect view itself. As Chris mentioned, here are two screenshots showing two different appearances. We have the Innis appearance named Vibrant Light to get this light appearance and light controls. And we have Innis appearance named Vibrant Dark to get the dark look and dark appearance. And notice the controls automatically look different and automatically are changing the colors as needed. It's easy to do this. You can just use visual effect view.appearance and set the appearance to either vibrant light or vibrant dark. You can do it in code, very simple. Or, as usual, you can go into Interface Builder, select your visual effect view, and when you select the visual effect view, the appearance property will now have vibrant light and vibrant dark as options. Other views won't have this option. So the vibrant appearances require an Innis visual effect view. I'm going to say more about this in a bit why. That visual effect view can be a direct ancestor, or has to be a direct ancestor, of your child views in order to get the vibrant look and the vibrant effect. However, whatever material is shown by the visual effect view may be different than what the appearance is saying. And let me describe that a little bit differently. Visual effect view has a property called material. The Innis visual effect material has several enum values. The first one is what you will probably use the majority of the time. Innis visual effect material appearance-based. So let me show you how that one works. If you have a visual effect view, and it's set to Innis visual effect material appearance-based, the actual material shown by the visual effect view is automatically determined by the appearance. So if you set the vibrant light appearance, the material light will appear for that visual effect view. If you set the vibrant dark appearance, the material dark will appear for the visual effect view. Now you can explicitly set the material and not set the appearance, which is why it's an enum option. So the last option here is Innis visual effect material title bar. And so what this material is for you to create your own title bar-like views. So you may have a need in your application to replicate the title bar that we do inside of AppKit. And we just use this Innis visual effect material title bar internally. And so you can also use it to create your own title bars if you need to. All right, so that was discussing visual effect view, appearance, and some of the materials. So now I'm going to talk about vibrancy and custom controls. First of all, well, what is vibrancy? And vibrancy is just basically a special blend mode where we're taking two different pixels, combining them together, and getting a different result that looks more vibrant when they're combined together. Vibrancy is just an abstract term that we coined in AppKit, and that way you don't have to worry about the actual implementation. The actual implementation and blending that we do could be a linear burn, a color dodge, plus D, plus L. It doesn't matter. We're abstracting it for you. But if you don't know what those terms mean, let me give an example. So here's just a simple image of some flowers. And if I drop a little square onto it, it's just a solid gray square with a darker border. And if I set it to be color burned, as you can see, it looks more vibrant. So effectively, this is what we're doing to our controls. And this is just a very simple example of what color burn and what we mean by vibrancy. So how does this work with visual effect view? And how does the text become vibrant? Let's take a look at what you have to do. First of all, in order to get any sort of vibrancy, you have to use the vibrant appearance. So you have to set the vibrant light or vibrant dark appearance, and then vibrancy is automatically and abstractly applied. So for this little piece of text here, in order to get this text to look vibrant, and it might be difficult to see, but it is actually blending with the contents behind the window, you just use InnisColor label color, and it looks more vibrant. You may also have a need for a secondary vibrant look, and this one's just slightly lighter and looks a little bit different. And again, we have a new color, InnisColor secondary label color, to achieve this vibrancy in an Innis text field. Now, let me remind you about some template images. You may or may not be aware that Innis image has had a template property since 10.5, and it's really simple. You can create your image as a black and white image and do set template yes, or have a specific naming convention to make it a template. And that gives you a template image where we can apply effects on top of it inside of AppKit. So if you're using a template image, Innis image view will automatically apply vibrancy. So here's an example of a regular image, not a template image, and it automatically does not have vibrancy. However, this image below automatically has vibrancy because it's using a template image. So if you in your application use template images, you can automatically get vibrancy. So that begs the question, well, how does something like image view say, hey, I want to be vibrant or not be vibrant, and how does it dynamically choose this answer? And the answer is, we have new API in Innis view to do this. And this is basically the implementation inside of Innis image view. It says, allows vibrancy is the new API, and the answer to allows vibrancy is self.image.isTemplate. So it's just saying, hey, if I'm a template, I can be vibrant. If I'm not a template, I can't be vibrant. Very simple. So you may be wondering then, well, how do I signal to the system that that's changed? What if my answer is changing based on something that I set, like change the image or whatnot? And just like normal AppKit things, if you change the state of vibrancy or need the question to be asked to you again, you just call set needs display, and we'll automatically call back and update the vibrancy effect for your view. Now, Innis text field also is vibrant. Innis text field behaves very similar to Innis image view, and it answers yes to allows vibrancy if you're using our particular vibrant colors. So if you're inside of a vibrant appearance and you're using label color, secondary label color, or any other colors which might be custom for that appearance, they will probably appear vibrant. If you don't want the text to appear vibrant, you need to explicitly opt out by setting the control text color or some other color that's not there. Innis appearance also has a method called allows vibrancy on it. This is so that you and your API can know if a particular appearance needs vibrancy or not. I'm going to discuss more about this in detail later. But what this gives us is it gives us a recipe to let you know when a particular view is going to be vibrant. Any view will be vibrant if all these conditions up here are true. The appearance has to say yes from allows vibrancy, which means currently that it's the vibrant light or vibrant dark appearance. Your view subclass has to override allows vibrancy and say yes. That view is expressing that it can be vibrant. And that view has to be inside of a visual effect view. The visual effect view is sort of the glue that binds it all together. If it's not contained inside of a visual effect view, vibrancy will not work. So when all these conditions are met, your control will become vibrant. So let's talk about custom controls in vibrancy and what you can do in your control to make them vibrant. So here we have a custom view. It's just drawing a gray oval and then another gray oval inside of it. And this one's appearing vibrant. You can see how it's a deeper orange color. The gray is being blended with what's behind the window to produce this vibrant effect. And when it's not in the visual effect view, that same exact view is drawing non-vibrantly. It's drawing its normal gray colors with no work from you, the developer. In addition, another thing to point out in this view, this bottom view here, it is inside of a visual effect view, yet it's not appearing vibrant. I'm going to discuss how to achieve that effect too in a short bit. How do you actually go ahead and implement this? Well, first of all, in your custom view subclass, as I mentioned before, you'll override allows vibrancy, and you'll probably return yes. That way, when you're in a vibrant appearance, you automatically will appear vibrant. And then inside of your draw rect, you probably just do whatever you're doing today. You set your particular colors, fill a path, or do whatever type of drawing you want, and it will automatically become vibrant. Here I'm just drawing with some regular colors, variation of black with a different alpha value, and this view automatically becomes vibrant. Now, because that view says yes to allows vibrancy, anything drawn inside of that view will automatically become vibrant. Even if you drew images, any text, any color, everything inside of it will be vibrant. You don't have to use label color or secondary label color to get vibrancy in that view. However, what you can do is you can utilize named system colors to have your application and your custom view be more dynamic depending on what kind of appearance it's in, if it's in a light appearance or dark appearance. So for instance, something like in its color control text color now is dark when it's on a light appearance and light when it's on a dark appearance. Something to be aware of, if you're taking these colors and storing them in your app, store the named color. Don't convert that color to a CG color, or don't convert it to a color space. Don't extract the RGB elements and save them off, because if you do that, you lose that dynamic nature of the color. Instead, just save the color itself, like the NS color, control X color, and utilize it again and again. Now again, if you change your appearance on your particular view, it automatically invalidates the subviews. So if you're holding on to that color, you don't have to worry about invalidating things. It's done automatically. So let's take a look at some code that uses a system color, because you may not be familiar with it. We have colorless, and so you can easily grab a colorless named system. And what this sample code is doing, and again, this is provided in that demo application I mentioned at the start, it's going to go ahead and set up some attributes. It's going to enumerate through all the colors in the color list, grab a particular color out based on its key. The key is the name of the color. Do a set of it, and just do a rect fill to fill that color, one after another. So if we look at a view where all it's doing is drawing those colors, and this looks very, very busy, so let me explain it. This is what we would get, and this is what that demo application does. So in the first column, this is just drawing the name of the particular color. Next column is drawing the same color, same view in the aqua appearance. Same color, same view in the vibrant light appearance. Same color and same view in the vibrant dark appearance. And if we zoom in so you can see one particular row, this is the control text color. And as you can see, the aqua, vibrant light, and vibrant dark, the colors are all slightly different depending on what we decide in AppKit to make it look for a particular appearance. The point here is they are different depending on your appearance. So if we take a look at that custom view again that was drawing the circles, if we used in its color label color and its color secondary label color, that view would look good if it's in a light appearance or a dark appearance without you having to do anything. Now, one of the things to note in this view, at that bottom, there is one of these custom views that's not drawing vibrantly. So how did it opt out of vibrancy, and what did it do? It's very simple. All that view is doing, and this is just done inside of Interface Builder, you could do it in code, is I have it selected, and I go ahead and set the appearance back to aqua, and so it no longer meets the criteria of being a vibrant control, and it won't draw vibrantly. So the things to note is that you can opt out your particular controls from vibrancy one at a time, or you can do it on a whole view hierarchy. So you could have a hierarchy of controls opt in or out by setting a container to be one particular appearance or not, and opt it in and out depending on what you need. One thing to note is your view that's apparent can't have already said yes to allows vibrancy, because there are caveats with that, which I will discuss in a little bit. Let's discuss how you would actually achieve something like this, where the same view, where it's in a visual effect view, it draws one way, and when it's in the regular aqua appearance, it's drawing another way. And in this case, when it's in the aqua appearance, I'm drawing red and purple just to be dramatically different. So why would you want to do this? Well, in your application, you might want to provide different artwork for when you're inside of a vibrant vibrant appearance than when you're not inside of a vibrant appearance and when you're inside of a regular aqua appearance. Or you could use different colors or something along that line. In this particular case, I'm just using different colors. And it's really easy to use. As I mentioned before, Innis appearance has a allows vibrancy property, and it's yes when it's in a vibrant appearance. And so your code can key off of that. Innis view has a method called effective appearance, where it finds out what the appearance is set on it or somewhere up the chain. And you can query that and see if it allows vibrancy. And if it does, you can set one particular color. If it doesn't, you can set another color. So here it's just saying the red color when it's not in a vibrant appearance. So let me discuss some caveats with vibrancy and blending. This is the within window blending mode and some caveats with it. So let's say that we have this super view here, the one with the gray or darker square around it, and it has some subviews. Now, if that super view says yes to allows vibrancy, what's going to happen is all the subviews are going to always be vibrant. And so it's a little difficult to see here, but now that subview, that image view, is doing a different blending, and it looks a little bit murky and muddy because it's doing a vibrant blending, and that's not desired. So the thing to be aware of here is if your custom view is returning yes from allows vibrancy, all your subviews are going to be vibrant. So if you're designing applications, you need to keep this in mind and design all your subviews to be vibrant or to be aware that they're going to be vibrant. Or design it such that your parent view is not saying yes to allows vibrancy, overlapping with the siblings or children. There are also some other caveats with behind window blending. It has that same once vibrant, always vibrant effect, but there's an additional problem here that I'm going to highlight. And what is happening here is I have this blue box, which is saying, no, I don't want vibrancy. However, there's a text field on side of it, which is using label color, which, as you know from before, is saying yes to allows vibrancy. So the text wants to be vibrant, but the thing drawn behind it wants to not be vibrant. However, those areas are overlapping. And we just described this to the Windows server. And so what's going to happen is anything in that square of the text is going to be vibrant, including what was drawn behind it, that blue area. And so it gets also vibrancy applied to it. So this is another caveat which you should be aware of and not do. Instead, you probably want to opt your text to not be vibrant or have that blue control to be vibrant so everything is vibrant. Another thing that we have is visual effect view can have a mask image property. The mask image allows you to mask it. So right here are two visual effect views, one using the light appearance or light material and another using the dark material. And if I set a mask image on each of them, just the area blending behind it to behind the window is only inside that masked area. So you just see that for the actual house icon or the gear icon. And what was drawn in the window, you can now see the poppy flower. And again, the demo application shows this. You can easily set a mask image, or you can use Innis image with size, and do the block handler to create it on the fly. And so here's setting it to be a Bezier path that's just a round rect. And when you do something like this, it's how you would achieve this, shown in the demo app, where it's a round rect for my entire window using the mask image property. Some notes about mask image. Chris highlighted some of the new features that we use with Innis image. So, set those cap insets so we can properly stretch the mask image, and everything will work fine. Okay, so that was discussing visual effect view, mask image, appearance, and how to get vibrancy. Let me talk about some of our standard controls in AppKit and how they do vibrancy and things to be aware of. First of all, table view and outline view, and a table view and outline view configured as a source list is automatically opting into a vibrant appearance now. So you see that in something like the sidebar in mail, calendars, etc. So how does this work? And how does this work with your applications already? If you're using the selection highlight style of Innis table view selection highlight style source list, that tells the table or outline view that it wants to be a source list. And as soon as you set that, either in code or in Interface Builder, it has always had side effects. And these are documented in the release notes, but I'm going to reiterate them here. Outline view's indentation is automatically affected and controlled to meet specific metrics. New to 1010, we start tweaking the intercell spacing just slightly to make it meet new metrics. If you're using a table cell view, its position of image view and text field are automatically controlled to what it needs to be. And we apply attributes to the text to make it appear correct. So if your application was using a source list highlighting before and doesn't make any significant changes, it will automatically get the new 1010 look for source lists in the sidebar. The last little bit here is the background color for the actual source list or the table is set to a magical internal color. And it's important to be aware of this. Because it has this magical color, what's happening inside of AppKit, when we see that you're using that special background color, we're going to go ahead and put a visual effect view behind your table view and do the blurring automatically for you, so you don't have to do anything. If you don't want that behavior, after you set the selection highlight style to source list, you can change the background color to anything else. You could change it back to clear or to nothing, and it will not do that operation. And this is the way it's always worked, and so we respect old behavior of opting out of that background color or the background blur, so you could do it manually in some other super view if you need to for some reason. Another note or thing to be aware of is now automatically in 1010, the sidebar source lists or table views automatically get the appearance set to the vibrant light appearance for you, and you don't have to do that. Another control inside of AppKit, Popover is now utilizing the light and dark materials as necessary, and it will have its appearance set to vibrant light or vibrant dark as necessary, and you don't have to do anything for that. So that was an overview of the standard AppKit controls inside of AppKit. I'm going to bring it back to Chris to talk more about performance and what you can do to make your app fast with these new visual effects.
Thank you, Corbin. All right, so that was fun. Talk about performance, which is also fun. So you noticed that blur we had, and this may not surprise you, but the blur effect isn't exactly free. It does cost something, and that something is graphics performance and battery usage. And sometimes, though, the cost is worth the results. So something you should be aware of here is you're not trying to not use this effect. You want your app to look beautiful. You just need to pay attention to striking a balance between that appearance and the resource utilization. So here's a small example. These two images on the left and right appear example. It's actually a control with 3 image views and these vibrant template houses. And you recall the vibrancy requires a visual effect view. So there's actually a few ways of accomplishing this, but on the left, we choose to accomplish this with a single visual effect view. Meanwhile, on the right, we can accomplish this with 3 visual effect views. And there's some obvious reasons to structure things on the right versus on the left. One of them would be flexibility. If you needed different appearances or different materials for those houses on the right, you would need to use visual effect views. However, you should be conscious about how many visual effect views you're using and when you're using them. In this case, the number of pixels affected here, the surface area of these houses, is almost identical between the left and the right. And in that case, a single visual effect view is going to be more performance. There's less information for us to track. The opposite of this case is also true. If you had a window with, say, some very small areas of vibrancy, and they were on different edges of the window, it might be more efficient to use 2 visual effect views instead of a single enormous visual effect view. Something else to be aware of, especially for in-window blurs, is frequently updated content. And what do I mean by frequently updated content? Well, I mean movies, I mean animations, I even mean blinking cursors. These are going to be updating at 24 or 30 FIPS or 60 FIPS for animation, or even 2 FIPS for blinking cursors. And the thing is, whenever these update, we're going to have to recompute that blur. This is also true for behind-window blurs, but you don't usually control the content behind the window in your app, so that's not something you really need to worry about. Corbin mentioned that layers are often required, especially for in-window blurs, and layer usage is increasing just in general. But something I want to mention is that if you're using layers, the dirty shapes on screen are going to be different than if you're not using layers. So here's an example of a mock text view that just blinks an insertion point in this R rectangle when it's not layer-backed. And you can see here we have this blinking cursor. What you probably can't see is I've actually turned on color flush in one of our debug tools, and this rectangle is turning yellow every time the cursor updates. For a non-layer backed view, that small rectangle is all that's flushed on screen. If, however, we say we do want a layer for this, we're still using the small dirty rect, but whenever the view updates, we see this instead. The entire layer is flushed. It's not that we're drawing anymore. Our application is still just drawing that tiny cursor rect. It's just that core animation has been built for GPUs, which involves submitting geometry in large batches. So we just flush the entire contents of the layer to the screen. If, for example, you had a visual effect view that overlaid the right side of this view, even though only the insertion point on the left is blinking, that blur is going to have to be recomputed. So that is something to keep in mind. Something else to be aware of, if you're using update layer or you have your own layer tree and you're setting your own layer properties like the corner radius or other elements directly, the entire layer is still going to be flushed in one pass there. So that caveat applies to update layer users also. Often, though, you can fix this by just refactoring your view hierarchy for a little. So, for example, if you have frequently updating content, try to put it in a small view and reserve large views for static or unfrequently updated content. Something unrelated but very important to be aware of, NS window has an opaque property, and you shouldn't mess with it if you're using visual effect views. In the past, if you needed to punch a hole through your window or have transparency, you had to set this to yes. However, if you're using visual effect views, you don't have to do that. We take care of it automatically. If you set this to no, you're going to take away a lot of information the Windows server uses to call obscured windows, and it'll be doing a lot more drawing than necessary. So avoid this unless you're already using it for other reasons. I want to point out this option in the accessibility preference. This is in the display subsection called reduce transparency. And that'll actually turn off our blurs on a system-wide basis. And I'm not suggesting this as a user feature. Instead, I'm suggesting this as a diagnostic tool. If you add a lot of visual effect views to your app and all of a sudden notice that maybe your window resize animations or your full screen transitions have become slow, you can set this to yes. And this will avoid the cost we pay when doing that blur. So if you notice when this is turned on, your performance is fine, and when this is turned off, your performance is kind of sluggish, it's probably you're either using a visual effect view that's too large or too many visual effect views, and that's a cue to dial down the transparency and blurring in the app. Some other things I want to mention is some performance tools we can use for this. So I used Quartz Debug to turn on a coloring of dirty areas that the Windows server had to redraw, and that can be very useful for diagnosing cases where you may be drawing more content than you're expecting, or when you're using layers and you're drawing a little bit of content, but it's affecting an entire view. Something I want to point out about a lot of our drawing here is that the blur effect actually happens out of process. It happens in the Windows server, and furthermore, it happens on the GPU, and that means that profiling your own process won't necessarily tell you as much as you would hope. I'm still ever going to call out the instruments tool, because the Windows server and your app are kind of competing to get frames on the screen in a single display cycle. And the faster you can make your app and the less GPU it utilizes, the more that is available to the Windows server. So you can still improve the performance of the system as a whole by just improving the performance of your app. And Instruments gives you the tools to monitor all of that. If you're just doing lighter development on your app, having Activity Monitor open can sometimes be useful. It's certainly not as in-depth as Instruments, but it will tell you how much CPU you're using, and more importantly, it'll tell you how much energy your app is taking to do what it's doing. And if you see that operating a little higher than you're expecting, that may be another cue that your visual effect view usage has gotten a little excessive. Finally, for the purists amongst you who really don't want to impact what their app is doing by adding some GUI stuff to profile it, you can SSH in and use sample, for example, which will tell you what your app is doing. So we've covered a lot, so I'm going to give you a quick summary of these things. I mentioned the NSIM and drawing enhancements, especially cap insets. I also mentioned the new behaviors of NS color, the importance of NS appearance, and some segmented control API. We covered new window features, especially the full-size content view, but also the title visibility options, so you can make your title bars look like Safari and Maps. We also covered the transparent title bar, which is what Notes and Reminders are using to have that crisp appearance all the way from the bottom to the top of their windows. Corbin gave you a huge run-through on NS Visual Effect View and what you can do with our visual effects and how appearances and vibrancy are accomplished. And finally, You'll just remember like 40 seconds ago, we talked a little bit about performance. And I do hope you'll take some of those performance messages to heart when you leave. Oh, thank you, Raleigh. One other thing I failed to mention, though, is the new NS Scroll View API that you would use in conjunction with full-size content view didn't make it into the seed you got earlier this week, but it will be available to you shortly. So I'd like to point out Jake Behrens, our frameworks evangelist. He is here in the plaid shirt and the dark, vibrant appearance shoes. We have taken to describing his appearance in great detail throughout the course of the week. I'm eager to see what we come up with tomorrow. We also, of course, have documentation available online. Developer.apple.com is also where you can get the Quartz debug tool I mentioned, and, of course, our developer forums. There's some related sessions. Adapting your app to the new UI was a session yesterday. That's available online now. Additionally, later this afternoon, there's What's New in Interface Builder, which will cover not only a bit of what we showed you doing with Interface Builder today, but other useful Interface Builder tools for designing your app. And tomorrow morning is Creating Modern Cocoa Apps, which if you found some of these new APIs interesting, that'll cover a lot more of what's gone into Cocoa recently. Thank you very much.